Hi, this is Declan Trezise. I'm the International Technical Director working for Basis Technology out of the UK. Today I'm going to walk you through a demo of Rosette Match Studio. Rosette Match Studio is an application built on top of our name matching capability, sometimes called Rosette Name Indexer or Rosette Name Matching. This demo is going to help you understand how our algorithm works, how it works with name searches and how it works with name comparisons, and really the underlying capabilities that allow you to get a human readable normalized score that shows the similarity between two names. The view that I've got in front of me allows me to start looking for names using a one-box search. What I'm going to do is I'm going to type a name in here, and I'm going to see if that name exists on a list that I've loaded already. Now, talking about this list is actually an index, and it's been put into Elasticsearch, and this has been combined with the Rosette Name Indexer plugin for Elasticsearch. Therefore, Rosette Match Studio is more like a front-end user interface sitting on top of that plugin integration. I'll start by typing a name, use an example I've used before, you can see it's in here. So the name is Jesus Lopez, and the list that I'm looking at is actually an extract from the OFAC list. The OFAC list is a public domain watch list of financial bad guys. It comes from the US Treasury Department, and you can find it online. Straight away, when I type in the name Jesus Lopez, what you'll see is there's a set of results here. The set of results are ranked by their score. You'll see that anytime there is a match score over 70%, we're actually going to highlight that score in green. And you see now I've got two potential matches for my initial name search of Jesus Lopez. One is Hernan de Jesus Lopez Zapata, and then Jesus Alfonso Lopez Diaz. If I was to try and further disambiguate between these names, I would have to add some more information. So if I just add a subtle addition here, an initial to the name that I search on, you'll see that after I hit the search button, we now have increased the score of one of them by a single percentage point and actually decreased the other one by a couple of points. So we now see that only one name is actually potentially a match in this scenario. So this aligns with our out-of-the-box capability, generally giving what a human would consider to be a match when the score is above 70%. And we've actually differentiated the second name slightly, so it just pops below that line. And the name here, Jesus Alfonso Lopez Diaz, has been strengthened in the confidence of the similarity, so the score has gone up, and that now is the only one above the line. There are many different variations that I can actually layer on top when I'm doing these kind of name searches. So this name could be manipulated in several different ways. So instead of saying Jesus Lopez D, I could maybe change the second name to a misspelling. I could maybe spell Diaz in a slightly different way, and we'd see that that name would still come at the top of the list. When it's different too much, the score will be not confident. So we might have to actually improve the match for us to see it's a good match. And this is where we're actually differentiating between what could be a false positive, which a name that looks a bit like the name, and a name that is considered to be the same by a human viewer. So let's start this over again. Let's give the full name in here. Here's one I prepared earlier, Jesus Alfonso Lopez Diaz, and we'll look at some of the manipulations that I can do. So why is this name, although it has all the same name parts, only giving me a 92% score? Well, in this example, you'll see that the version in the index has the names in a different order. We have first name, first middle name, second middle name, surname there, and then separated by a comma. Also, you'll see there's different capitalization going on here. So this name actually has capitals for the first two names and then full capitals for the second names. In mine, I've completely left the case the same. Now, what if I then start adding other manipulations on top of this? So like we saw earlier, I could misspell one of the names, but actually maintaining the sense of the name, there are some things that happen all the time. For example, somebody losing a space between two of the names. When I hit the button, you'll actually see the score doesn't change at all. So our algorithm is actually immune to that kind of transformation. The other examples might be reducing this to an initialism. So Jesus A. Lopez Diaz. Now we still have a very highly confident score, 88%. And also, maybe if the name Jesus was spelled incorrectly, perhaps if it was spelled in a phonetic way with an H, and then maybe a Z in the middle. So now Jesus spelt with an H. And here we still see we have an 80% score. You're probably wondering how this name match actually works. And what I can do is I can dig into the matching engine and pull out almost like an audit trail, a sense of evidence of what contributed to having this name match this version on the list. And I can do that right now. So if I start to expand this out, you'll see that there was a single field. It was actually the name, person name field that contributed to this. So in other examples, we might start to use some of the other attributes, but here I'm really talking mostly just about the name matching. Let me dig into this next section where I can actually do a side-by-side comparison of two names. So now we have the name that I searched with and the name that came back from the index. And underneath that, we have the match score. And then underneath that, we actually have the match score computation that's been spread out over a matrix. And this shows which parts of which names matched, how strongly they matched, and how much they contributed to the overall final score. So we see that there are different weightings for the name parts that were written in the index form of the name. The name weightings refer to the length of the name and also how common that name is. And sometimes there might actually be differences in weighting based on the position. So there might be a boost to the end of the name, or a boost in the middle, or a boost at the start. We see that again here, a very short name. The initial actually only contributes 4%. The actual full names support more. And Jesus spelt incorrectly actually has a very high weighting, because this doesn't come up in any kind of analysis of a population looking at how common names are. So we say that uncommon names are potentially more differentiating. And even though there's actually only a low match between Jesus and Jesus here, when you multiply the weightings by that low match, it actually has a high contribution to the overall score. Looking at the different match types, we've got 3 expressed in this example. We see that we have what's called an HMM match, and if I hover over that, we see that this is using a fuzzy match statistical model. So basically it's using the phonetics of the name to form the match. It's how it sounds when it is spoken, which is how the algorithm understands that these two could be related to each other. Here we have an initial match, so A matches Alfonso. So one token is the initial letter of the other token. And here we have an exact match. So we know that Lopez Diaz matches Lopez Diaz, absolutely. You'll also see that these matches on the grid are at slightly different offsets in the whole view. So it's because they're actually out of order. So what I'll do is I'll show you the absolute canonical form of both of these names and what a perfect match would look like. And then I'll layer on some manipulations on top. So here we go, Jesus, Alfonso, Lopez Diaz. And I'll take the exact same form of this name and put it in here. So when we have the exact match, we see in the grid a full alignment right directly down the axis in the middle. And every one of them is an exact match score, giving a contribution of 1 or 100% for each case. When I start to do small manipulations, you'll see how these affect it. So if I was to join 2 of these together, that's something that we're immune to, because our engine understands the ability to tokenize and split out names that have been concatenated together. When I change the Alfonso to an A, we then see an initial match, and the score drops down by 6% overall, which is based on the fact that the weightings multiplied by the match score mean that it's diminished by that amount. I can also go back to that variant on Jesus, and we see that becomes a hidden Markov model match, which is our fuzzy statistical match using the phonetics. Okay, and Lopez Diaz have been joined together, and overall we get that exact match score. So that's still over 81%. A lot of engines would actually struggle with this example. But what if there were other things introduced? What if we had a typographic error, a typo in there? Then our HMM matcher kicks in for this one. Or what if these two names, instead of being joined together in the correct order, were joined together in an incorrect order? Here we see that the tokens get split out again. Here we see the exact match on Diaz and the phonetic match on Lopez. So we're still getting over 73%. Now there's some other things that are built into this algorithm as well. So Jesus, might be spoken to, might be referred to as Jesus, but actually that as a nickname or as a street name or a cognate name or even a synonym for his name, somebody might use the name Chewy. This is actually a common variant of the name Jesus in South America. And here we see that we get an override match. What this means is it's using our list of synonyms to actually contribute the match score in this case. So where there is no direct phonetic match, we can use this override list, and this allows customization of when things should match based on either nicknames, like I said, cognates, or synonyms. So now we still have a good strong match, but this name looks very different from the original form. There are several other ways that I can make this different from the original form as well, and I'm going to branch out now and talk to you about multilingual match examples. So this is just all written in Latin characters currently. I'm matching a highly variant version of the name with layered name phenomena on top of that. But really, what if this name looked considerably different? What if instead of being written in Latin script, it was written in Cyrillic script and it was a Russian transliteration? The example here is going to show that I can match characters and words in a different language without doing a translation or a transliteration myself. And what we'll see once I put it into the language detection format, there we go, that I can actually get a 97% match between the name written in Russian and the name written in Latin. And even if I was to do some of the similar things that I saw before, for example, just leaving an initial or just or doing a concatenation, in that case I could still get a high match, even though I'm doing a fuzzy match with a different script and a different language for the name. Now I can look at some other names as well. So what if this name had actually been sounded out into Chinese characters? So now I have the whole name, it's been written in Chinese characters based on the way that each of these characters sounds when it's been pronounced. So maybe the pinyin form of each of these characters. And what I do when I get the language detection added on, here we can see we're using the phonetic matcher in each case, and we can see it's a potential reading for these names based on the pinyin, but also we can see what happens if we were to run this through our matching engine for the phonetics. And overall we get an 85% match, despite the fact that this is a very, very different language, very different script. The engine understands that these characters should sound the same. And one final example, going by this here, I can take the same name. This time it's going to be written not in Chinese, but actually in Arabic. So I put the language detection on again. So one of the features actually included in Rosette is the ability to detect the language of a name. I can run a comparison, and here I can see it's not the best match, but this is because it's using the general model for this name match. So if I was to be able to force this over to do a person match, you'll see that when I search with this name, I can get a higher score. So in this case, because it knows it's a person name field, and I run the search, we can actually see it pushes the name over the 73% score. So although using the generic match, I still would have got that name to the top of the list, actually by having a person-specific attribute tagged onto this name, we get a better score overall than we did just from doing the side-by-side. So this is a very short demo, just showing you name search using Rosette, specifically the Rosette name indexer plugin for Elasticsearch, showing you the name matching capability and giving you normalized, human readable and human referenceable and relatable scores for names that can be found. This has direct application in use cases such as border control. For example, Customs and Border Protection in the United States use this algorithm. It can be used for financial sanctions checks. So should you be working with a bank, you're asking to open an account or you're making a transaction, they will do several checks against names in order to see whether they're on certain lists. For example, the OFAC list. They could do anti-money laundering checks, know your customer checks, onboarding checks, and all of these involve name lookups against a list, which could be thousands in this case, or it could be tens of thousands or even millions of names. So having an algorithm that works directly with a fast text search engine such as this would show an advantage. So that's all I've got for today. Thanks for watching my demo, and I hope you learned a little bit about the Rosette name indexer demonstrated in Rosette Match Studio. Thanks.